Hello everyone. So let's now solve practice assignment week 8 question number 8, 9 and 10. It's a comprehensive type question. With a particular frame of reference in R2, the position of Rahul's house is at the point 8, 1. There are two roads, road 1 and road 2, along the lines y equal to 2x and y equal to minus 2x, respectively on the xy plane. Answer the question 8, 9 and 10 using the given information. So the first one talks about the which of the following options are true, and the option for basically if Rahul wants to travel the minimum distance from his house to road 1, then at what point he will meet, and while option 3 and 4 is about if he will travel from road 2. So basically we have to find the minimum distance with respect to road 1 and road 2. Okay, so the Rahul current position is 8, but position is 8, 1. Now, if he wants to travel the road 1, then the road 1 equation is given by y equal to 2x. So, if we check the corresponding subspace for this line, then let's consider this as subspace V1, then it would be of all x, y such that y equal to 2x, xy belongs to R, and that is same as writing that x, 2x, x in R. So this is the subspace, and if we check, it is same as the span of 1, 2. So now we want to calculate the minimum distance for this point along this road that is given by this subspace. Sorry, that is given by this subspace, and that is same as projecting this point onto this subspace, as we know that the minimum distance would be just a perpendicular line. So for consider this to be our some axis, and at comma 1 would be some point here, and for the line y equal to 2x, that would be some line like this. So if you want to basically find the minimum distance of this point along this line, that would be just the line perpendicular to this point, joining this point 8, 1 to the perpendicular on this line, and that is same as projecting this point 8, 1 onto this line, that is y equal to 2x. So we will find the projection. The projection formula for projecting a vector on a subspace W is given by the inner product of vector V with W divided by norm of W times W. Now this is for case when we are projecting a vector on a subspace having uh, dimension 1, that is the basis for that subspace is 1. If we have the greater than 1 dimension subspace, then we will this formula will be summation from I equal to 1 to some k wi, where w is the span of w1, w2 till some wk, and these are the orthogonal set. But we don't need to care about that much as we only have one dimensional space, and so that would be just simply so projection on subspace v1 for the point 8, 1 would be given by inner product of 8, 1 with, now here our basis would be 1, 2 divided by norm of 1 comma 2 and multiply with this vector. So this would be, so it would be norm square here, my bad, 10 by 5, 1 comma 2. Here I write it wrong before. It would be norm square, not the norm. So this would be 2 comma 4. So that means the point which would be closer uh, to the point 8 comma 1 on this line would be 2 comma 4. And if you look at the option 1 is correct, while option 2 is wrong. Now to check for the option 3 and option 4, we will do the same thing. So road to equation is given by y equal to negative 2x, consider it to be v2 all x comma y such that y equal to negative 2x, x and y sum from real number, v2 is x comma negative 2x, and that is same as span of 1 comma negative 2. So we will project 8 comma 1 on v2, that would be inner product of 1 comma minus 2 with 8 comma 1. Now instead of writing norm square, I can also write it as like 1 comma minus 2 with 1 comma minus 2, as it is same as the norm square of 1 comma minus 2 multiply with 1 comma minus 2. If we simplify, it would be this, and if we check, the option 3 is the correct and option 4 would be wrong. Let's solve question 9 now. Let theta be the acute angle between rod 1 and rod 2. What will be the value of 5 times cos theta? We know that cos theta between any two vector would given by the inner product between the vector, let's consider our vector u and v, divided by the product of the norm of those two vectors. Now here our vector are with respect to rod 1 and rod 2, and rod 1 is the span of vector 1 comma 2 and rod 2 is 1 comma minus 2. Now notice one thing, that it is given that theta is an acute angle, so the modulus sign will come. As we know, the cos theta value when theta is an acute angle would always be positive. Now this would be the modulus of inner product 1 comma 2 with 1 comma minus 2 divided by norm of 1 comma 2 multiplied with norm of 1 comma minus 2, and that would be 3 by 5, and this is the value of cos theta, and cross multiply 5 times cos theta is equal to 3, and that is our answer. Let's solve question number 10. Let this denote the standard inner product, that is the dot product. Suppose W1 is xy such that y equal to 2x, and W2 is all xy such that y equal to negative 2x. That is, this is our rod 1 and this is our rod 2. R2 subspaces of R2. Which of the following options are correct? So options are about the orthogonal complement of the set W1 and W2. So let's now solve that. So first, let's find the orthogonal complement for the set W1. Our subspace W1 is given by all xy such that y is equal to 2x, and that we know is same as the span of 1 comma 2 that we have just drawn. So that means W1 perk is the set of all xy such that inner product of xy with 1 comma 2 is equal to 0, and x and y are some real number. So that is all xy such that x plus 2y is equal to 0, and that is x equal to negative 2y. And if we check for the W2. W2 is given by all xy such that y is equal to negative 2x, and that is, it is a span of 1 comma negative 2. And if we want to find the W2 perp, it would be set of all xy in R2 such that inner product of xy with 1 comma minus 2 is 0. So it would be all xy in R2 such that x minus 2y is equal to 0, and x equal to 2y. So now let's check the option. For W1 perp, we got x equal to negative 2y, and that is the third option. 2y equal to negative x, same thing. So option 3 is correct. For W2 perp, we get x equal to 2y, and that is fourth option, 2y equal to x. Thank you.